All right, we are live, Samsher.
Yeah,
Welcome back to another Cloud Native live stream session. Super excited to be here with you today. Lots going on at Platform 9, obviously.
right.
This new product, excited to discuss what that's all about. And what's going on with you. I mean, this whole journey with this new product. Just bring everybody up to speed, and then we can kind of dive into it a little bit.
Yeah, sure. So, hi guys, I'm Shamshir. Joined Platform 9 almost 6 months ago as a technical product manager. I've been working on a lot of things, but today I'm really excited to talk about a new revolutionary product, which is actually going to help you improve your utilization on Kubernetes and save your cost in EKS. Right.
Yeah.
So, do you want me to share screen
Yeah,
quickly and then
before
we
we
can?
before we jump in, I think let's set the context here a little bit,
Yeah,
right?
yeah,
So why are we tackling this problem, right? So the whole issue in the industry is over the last year and a half,
right,
the whole cloud cost thing became top of mind for a lot of people,
right,
and part of that is because there are a lot of economical headwinds. People are really tightening their belts. They're trying to see where the waste is happening in the companies.
mhm,
So they looked at the cloud costs and said, "Oh my God, this is really going through the roof." Right?
right.
It's not new, by the way. Cloud costs have been around for since the cloud began. Right? People were spending a lot of money on it.
Yeah,
The whole thing about the growth at the cost at all costs, that whole concept is being questioned now. So I'm
right.
just setting the context in what's happening in the tech industry,
Yeah,
and that's why this whole FinOps movement started. Right, the
right,
whole financial and operational pieces coming together, and people really digging in and finding out where the costs are going. Right, public cloud costs obviously is one of the key ones, and within that, I guess the big question, I guess I'd love to hear your thoughts on this, Samshare, is
yeah,
before we dive into the topic for today, right? So we set the context for why cloud costs has become an issue, but what are the reasons for the cloud cost, right? And one of the things we have noticed and is that one of the issues has been about efficiency in the cloud
right.
and utilization, right? Which is really what we want to dig into today. So I did a just before this session, I went into Amazon and AWS and said, okay, let me kind of see what the various compute instances are
Hmm.
and what their costs are, right? So I just did a quick math, and nothing new. This has been around for a long time.
Right,
But what shocked me was there are over 150 plus instance types,
right.
compute instance types, from a tiny instance to a mega instance to a bare metal instance. And it's just, my mind blew up. I'm like, how am I supposed to select the right instance size for my workload?
Right, right, right.
Therein lies the first problem, right? How
Yeah,
am I going to select the right one? Because if I don't select the right one, then I'm just leaving a lot of compute and memory on the table,
right.
not using it, right?
Yeah,
So I just want to set that context first. And in the Kubernetes
hmm,
situation, one would think this problem is solved, right? But it isn't.
right, right.
So let's dive into that and talk about what you're seeing with Kubernetes and what is the whole reason why we started working on this new product.
Yeah. So I think, like you mentioned, there are 150 instance types available on AWS, and the reason for that to be available in a different sizes is because Kubernetes is becoming the de facto standard for running workloads on the cloud, right? And everybody wants to use a different hardware type, different configuration, different uh, parameters that they want to utilize on different instances. If they use a bigger size instance, then they will have to pay a lot of cost, right? So that's one of the reason that AWS started to split that into multiple variations. But that is getting confusing for everyone because it's extremely hard to choose the right instance for your workload, right?
Hmm.
Even if you choose the right instance for your workload, which is running on cloud, after a certain period of time or some time when the spikes happen, that instance types will not be able to handle your workload. So you might
Right,
have to take a decision to actually move your instance to a different type, right?
right.
And I think the AWS is confusing people to choose between different variations because they want to obviously earn money, but they also want to give a flexibility and they want to allow users to decide which instances they want to use,
Yeah,
right?
yeah. So this is an important point, right? So there are so many variations. so many different instance types.
Yep.
You can pick what you want, what you think you want, right? And but then AWS is giving you exactly what you're asking for,
Right.
right? If you say I want 64 gigabytes of memory and 16 CPU vCPUs, they're
Mhm.
going to give you exactly that,
Right.
not more, not less,
Yeah.
right?
Yeah.
And then it's completely up to you to either use it or not use it,
Yeah.
right?
That's
Whether
right.
you use it or not, you're still paying
Yep.
the full amount for that instance type,
Yeah.
and therein lies the problem, right?
Exactly.
So
Exactly.
let's dive into that. Let's see. I would have thought that Kubernetes is like this smart thing that knows how to pick the right instances and automatically take care of all of this. It apparently doesn't.
Yeah. So everybody thinks in the same
Yeah,
way that
yeah,
once they start using Kubernetes, all their problems will get solved.
yeah,
But this is not the case. This is not the
yeah,
reality, right? So the
yeah,
problem is
yeah,
once you start using Kubernetes, there are a lot of things that you will have to learn. There are a lot of concepts and ideas that Kubernetes introduces, and
yeah.
also put more stress on DevOps teams and like ops teams to really decide which one to pick for their workload, right?
So one question I have here is, again, now we're into the Kubernetes world, right? You're scheduling containers, you're writing microservices apps, you're basically Kubernetes takes your pods and schedules them to run on various nodes.
Mm.
Does Kubernetes actually pick the node size, or do you have to say, hey, Kubernetes, use this instance type? How does that work in the Kubernetes world?
So basically what you really have to do is you have to first, when once you create the Kubernetes cluster, so let's take an
Hmm.
example of EKS, right? You create a control plane and then you add managed nodes, right? Those managed nodes are of a different configuration, like maybe 16 GB of RAM and 64 gigs of memory, right? And say suppose you have created four different nodes which gets attached to your control plane, right? Now all of those are empty right now. Once you deploy your application on Kubernetes EKS, the scheduler actually decides where to place this pod, which which node it will get deployed to, right?
Hmm.
And
Hmm.
based on that, it takes a decision, and whichever node is available, depending on what user is requesting, based on request and limit, which is specified in the pod specification, it gets deployed to whatever node is currently available that will fit the requirement of the pod, right?
So it is doing some right sizing, right, or not?
So it's basically not doing any right sizing. It's actually putting your pods on whichever node is having available resource that is
Hmm.
actually going to match the requirement. So I'm going to talk about that in
Okay.
detail.
Okay,
Maybe
let's
I
get
can,
into that.
yeah.
Yeah. Yeah.
I think I'll share my screen and then we can
Okay.
start going into more details about that. Hope you can see my screen.
Yes.
Yeah. So our topic for today's discussion is tackling the kids underutilization, which will
Hmm.
ultimately help you reduce the cost like by 50% on your EKS, which is deployed on AWS, right?
Hmm.
And there are two parts here. First is the underutilization of Kubernetes, right? And then we will talk about how, you know by using Elastic Machine Pool, which is a new revolutionary product introduced by Platform 9, we can actually reduce the cost by 50%,
Hmm.
right?
Hmm.
So I'll not go through the introduction. I'll just first jump
Yeah.
into what is the current Kubernetes market share, because now we are going to talk about Kubernetes, and it's
Hmm.
really important to understand what's where Kubernetes stand currently, right? So if you
Right.
see the market share of Kubernetes on a different cloud provider, like I'm going to focus only on three because these are the major cloud providers. AWS is actually acquiring almost 48% market share for Kubernetes, right? Followed by Azure, which is 32%, and GCP, which is 20%, right? And that's one of the reason Platform 9 Elastic Machine Pool wanted to first target AWS, because that's the most approximately 50% of market share is there for Kubernetes, right? And to be honest, working after working on Kubernetes for more than 5 years, I realized that Kubernetes is not really efficient
Hmm.
consumer of infrastructure. Like, so once you deploy your application on Kubernetes, there are a lot of things that's left unused, right? Because you think that this is the resource requirement which is necessary for my application to run, but that will never hit the point where it will use the entire resources which is available on the node,
Yeah.
right? So
So just to clarify here, when you say resource,
Yeah.
you're referring to a compute instances,
Yeah.
and within those compute instances, you're referring to CPU and memory, correct?
That's correct. That's correct.
And this 30% refers to what? CPU or memory or both?
It's basically an aggregation of both, like CPU and
Okay.
memory combined, because that's what you get when you ask AWS to provide the instance type, right? It gives you a combination of memory and CPU, and
Hmm.
based on that, they will charge you hourly, monthly, and
Yeah.
cost on a different instance type, right? So, based on the EKS utilization, it's only using 30% of what is actually allocated, right? The rest of the 70% are actually waste, and
This is
that's why,
actually this data point is pretty shocking
yeah,
in a way, right? I mean,
yeah,
I would have assumed if I just got an EC2 instance by swiping my credit card and using it, then it's up to me whether I use it or not. But
right,
in the case of Kubernetes, I would have expected it to be much higher.
right.
So why is it so low?
Yeah. So before we jump into that,
Mhm.
I wanted to share some other metrics with
Sure.
different prospects and customers that we have been working on
Yeah.
for this product, and we talked to different customers and prospects across different companies, different verticals, different domains, and this is what their utilization of CPU and memory, right? And as you can see, they are mostly using 15 to 20% max, and like if you see in the SaaS data management company, their CPU wastage are approximately 83%, and memory bits is almost the same, right?
Mm.
For AI platform, loan AI platform, 95% CPU is waste, right? So they're only able to utilize 5% from that, but they're actually paying for the entire amount, right?
Yeah.
And these are the different metrics with the different companies that we talked to, right?
This is across all of their EKS clusters,
Yes.
right? Over a period of time. I'm assuming it's some sort of an average or something.
Yeah,
All
yeah.
right.
So it's aggregated
Yeah.
and based on average for 1 year approximately,
Yeah. Yeah.
right?
Oh,
Because
wow. Okay.
that's when you decide, right?
Yeah.
Because
Yeah.
so sometimes your usage is high, sometimes it's low, so you cannot
Yeah.
decide that in a single month, right? So it's
Right.
aggregated based on a 1 year of period, right?
That's right. Because there'll be peaks and valleys, right? Depending on demand and so on. Okay.
Right, right, right.
Okay.
So there is another metrics published by Datadog in March 2023, where they're also saying the same thing, right? So requested memories, or 45% of containers are only able to use 30% of the requested memory, right?
Mm.
70% is actually the waste. And that's when the actual problem of Kubernetes happens, right? Because once Kubernetes allocate resources based on the part specification, it's kind of like a static. It will never change unless and until spikes happen. Your pod is actually using more memory, then it start to see whether it will fit on the node or it needs to provision another node, right? That
Mm.
completely depends on how your configuration is set up, right? So before we go into the details of how that underutilization comes into the picture, we first have to really understand how Kubernetes actually work, right? And this is very basic structure. You have a master node, you have a couple of worker nodes, right? This master node is deployed on EKS as a control plane, and these worker nodes are actually attached as a EC2 instances, right? And once the developer create a pod specification, they actually use kubectl to apply those pods, and it will go to API server. And then based on the requested memory and the limit, uh, the scheduler will decide on which node this pod needs to be created. It just decide it just calculate all of those based on the requested memory and CPU that
Mm.
the developers
Does
put.
it know which instance type to use?
Currently, it's basically not, because this will give you. So if you have a four nodes, like I mentioned, it
Hmm.
will put those nodes depending on whichever node is really available resources for those pod
So
specification.
when you say available,
Yeah,
is that like a pool of resources that are there, or how does it? So you have to spin up these nodes, I'm assuming, right?
right,
These VMs should be available
right,
first,
right. That's correct.
and
That's correct.
somebody else is doing that already,
Yeah.
and
So
telling Kubernetes, hey, you've got this pool of 10 VMs
right.
that you've already spun up, different instance types, I'm assuming, and
Yeah.
then Kubernetes decides amongst those pool of nodes which one to pick.
Yes. So we will see that how the EKS structure is, because we are going to target more specifically for the EKS. But this is just to understand how Kubernetes work and how it actually schedule the pods on different nodes, which is attached to control plane. The scheduler actually looks into the pod specification, and then it deploys the pod on any available node, right? So it's the responsibility of the scheduler to really pick which node the pod will get deployed to, right? And it does that based on certain calculation. The first thing that it looks into is the requested memory, right? So there are two things in pod specification. One is request and another is limit. The request is basically how much your pod will guarantee to get the resources on a specific node, right? So scheduler will actually decide based on the requested memory that which node it is going to be placed on. So if you have two nodes, and in some of the nodes the space is available, it will see whether this pod will be able to fit on that specific node. And based on that, if it will not be able to fit in that specific node, it will look for another one. And based on that, it will decide which one to pick and which one to decide, right? And there is another project by Kubernetes which is called descheduler, which
Mm,
basically kind of like opposite of scheduler. What it does is it actually looks for which node is more utilized, right? And which node is underutilized. So you can see here the green boxes, these have been completely full. The first node is completely full, and the other one is having the less resources allocated to that node, right? So the rest of the
mm,
things are wasting, right? So
mm,
what it will do, it will try to balance it by deleting certain pods from this first node and then putting those nodes on the another one, right? And it does that once the pod is deleted. The replica set will actually look into, because we have a desired state mentioned in the pod specification, how many replicas you want. It will go ahead and try to find another node where the more resources are available, right? So this is another project which is kind of like opposite of scheduler, where it will
mhm,
try to rebalance between different nodes, but it does that by actually deleting the pods, which is kind of
mm,
not that good, right?
mm.
Right. So now let's look into. I
Wait,
mean,
wait, that's an important point.
yeah.
So if you go back to the previous one,
Hmm.
deleting the pod is not good because basically, so you delete the pod on one node and basically restart the pod on the other one,
Yes. Yeah. Right.
correct?
Right. Right.
Which means there is some downtime,
Exactly.
and that's the problem,
Right. And that's the
especially for
problem.
mission critical applications which cannot tolerate downtime.
Exactly. Definitely.
Things like stateful applications
Yeah.
or databases or
Exactly.
in-memory apps and all of those apps, they cannot tolerate this, I would assume, right? Is that
Right,
correct?
right.
Okay.
And that's the actual problem. And that's why, you
Mhm.
can use rescheduler. There are different policies that you can define
Yeah.
on, which threshold you want to reach when the node gets full
Yeah.
or those things. But
Mhm.
you
Yeah.
look at this, that the cross boxes, like it will delete the
Yeah.
pod, and then the scheduler will actually look into where this pod needs to be created, and based on the available spaces, it will
Yeah.
recreate those pods. So just keep in
Yeah.
mind that this
Yeah.
this is going to delete the pod.
Yeah.
And I'm going to talk more about that in the future, but
Mhm.
just keep that in mind that it will delete the pod, right?
Yeah.
Now let's look into how actually the resource request will work and how it is going to schedule a specific pod that you create on a specific node, right? So developer creates this pod specification, and for this specific container, the developer will specify request memory and CPU, right? That means this pod, when it's get created, it actually needs 2 GB of RAM and 2 CPUs, right? So what scheduler will do, based on this specification, it will try to see which node is available. Now consider the node is having 4 CPUs and 8 GB of memory. What it will do, it will see that there is no pod available in this, the resource is completely unused. What it will do, it will try to schedule this pod on this specific node. So it will use 2 CPUs and 2 GB of memory, right? Now we have 2 CPUs left and 6 GB of memory available on this node, right? So what will happen when the next pod gets created? Now the next pod, which is pod B, it is also requesting the 2 CPUs, right? But it is requesting 4 GB of memory instead of 2 GB, which was available in pod 1, right? So what scheduler will do, it will see that this 2 CPUs is available on this node, right? And memory is also available. So what it will do, it will just go ahead and create the second pod, which is pod B, on this node. Now you see the white space, right? The
Mhm.
2 GB. So pod A took 2 GB, pod B took 4 GB, which is kind of like six GB of memory, but this 2 GB is left unused, right? And this is white because once you create the third pod, what scheduler will do, it will try to see whether it can fit the third pod into this node, but there is no CPU available, right? So it will
Mm.
not schedule that pod here. What it will try to do is it will look for another pod, another node where this can fit exactly for
Right.
2 GB and 2 GB, right? So this
Yeah.
this white space is always unused unless and until you need to create 2 GB of memory. But again, there is no CPU available, so this will always be left empty, right?
Mm.
And this is good for 2 or 3 nodes, but imagine you have 200 or 500 nodes, right, which is attached to different EKS cluster.
Mm.
This 2 GB of memory will always left unused, and you can never allocate any pod on this specific node, right?
Right.
Now look at the second case, which is a resource limit. Now, similar to resource request, you can actually specify what limit my pod should go, and after that it will try to get killed, right? So for example, you have to specify CPU limit, and you also have to specify memory limit, right? Once you specify more than what is required for a CPU which is available on the node, what it will do, if you deploy that on a specific node and that node don't have available CPU, the CPU will start to throttle and the performance will start degrading. But if the container is actually going to use more than allocated limit, right, it will get killed. And that's why you see out of memory killed issue on Kubernetes, right?
Mm.
The solution to that is you use some kind of autoscaler which will try to find out whether this node can be, or whether this pod can be fit into another node, right? So what happens is, just imagine that you have some space left on your node which will never get used by any pod because the CPUs are not available. Or either if you were specifying higher CPUs but lower memory, or lower CPU and higher memories, there are always some space which will be left on your node which will never be used, right? And Kubernetes actually never frees those resources. Once these pods getting created on any node, it's, think of it as a static allocation on a specific nodes. Unless and until that pod requires more memory and more CPU, it will not move into another node. So like I mentioned, it will get destroyed and recreated on another node if it is requiring more limit, more than the limit which is
Mm.
specified, right? So it will never free the resources from your specific nodes, right? And that's when the underutilization problem is. Now you can see here this red one is actually resource utilization on one pod, and this is the resource utilization on another pod. But this is the green box which is actually allocated resources which is never going to be used. And there are some free spaces which will never be freed because Kubernetes will never move those pods to a different one, right?
Mm.
So these are a couple of problems currently which is causing the utilization to be lower in most of the public cloud. And that's why customers are frustrated because they pay for the entire node but they're actually not able to use most of the space, right? Now, this is one of the sample data we have got from one of our prospects, where they have averaged it based on more than 200 nodes. So the 17% that you see here is, this is the actual capacity they are able to use, right? And they want to maximize it because this yellow one is actually the wasted due to inefficient bin packing. Kubernetes is not able to properly fit a different nodes on a specific different parts on a specific nodes, right? So
Mm.
this will be allocated but unused, right? This will never be used. This will be used sometimes, but most of the time it is left idle because the spikes is not happening, and the pods is not using most of the allocated CPU and memory. And the allocated, but the 34%, this is actually never used, right? So they pay for the entire node but they are only able to utilize 17%. Mm. And that's actually the problem. Now they've used a couple of other tools like Spot IO and Carpenter, that's on helping them bin pack better and spin up a right size nodes. But even using these different tools, they are not able to increase the utilization. The utilization is still the same because Kubernetes schedule these pods based on the requested resources, right? It's not actually going to allocate based on the usage. And that's one of the things that we are trying to do with Elastic Machine Pool, right? So okay, so we are actually able to use 70% of the nodes capacity, right? So you
Mm.
see here the before EMP part, which is Elastic Machine Pool, that the customers are not using, they're only able to utilize 17%. But once they start using EMP, this utilization is increased, and there are a lot of things that we are doing in behind the scene that is actually helping customers to utilize better. And
Mhm.
this will also help them to use less number of nodes, because they are able to fit more parts on a allocated nodes that they provision, right?
Yeah. So one couple of things you just said, Samsher, that I thought were pretty interesting. One of them is you said that there is no tool or solution in the market today that can actually increase utilization.
That's
If you go back to the previous slide, the red portion,
yeah.
that red portion
Mhm.
is lays waste because Kubernetes doesn't do anything with it.
Right.
Spot doesn't help you with it.
Yep.
Tools like Carpenter, I don't know what else is out there, but all of them are trying to solve the yellow portion. I'm
Exactly.
assuming, is that correct?
Yeah, that's
When you
correct.
say bin packing, what they're trying to do is to find the right, maybe just reduce the size of the instance,
Right.
so your allocation, you're not wasting your allocated resource.
Yeah. So they will give you a
Right?
recommendation that
Yeah,
they will have to apply this resource and
yeah,
this limit. But
yeah,
that completely depends on DevOps team and the ops, on basically the operational teams, who are
yeah.
going to decide which memory and which CPU they have to allocate. So they gives you a lot of recommendation, but it's up to you to decide which one to pick, right? And that's where everybody makes a mistake, right?
But this is back to the problem we talked about earlier.
Yeah.
You have hundreds and hundreds of instance types,
Right. Right.
right? And if you have hundreds of nodes, how can you even possibly do this manually?
That's true. That's true. So there are other tools available
Yeah,
like Spot IO and Cast
yeah,
AI, which
yeah.
actually helps you. They actually recommend you to use the right instance type from
Hmm.
AWS and other cloud providers, but
Okay,
they will not actually move your application to these instances. They will,
right.
help you decide which instances you have to use. Now, again,
Okay,
it's the human decision that needs to be picked in order to increase
yeah,
or
yeah.
efficiently solve this problem.
So what happens here? Here, so the DevOps person gets the recommend. So let's go back to the next slide
Yeah.
where you said EMP increases utilization. This increase of utilization to 70%
Mhm.
in the case of EMP, and we'll talk about what EMP actually does. I'm
Yes.
assuming it does it completely automatically
Yeah, that's true.
without a person being involved, right? That is the magic
Yeah.
that's happening here.
Yeah.
So let's talk about that.
Yeah, sure. So now just remember this picture that
Mhm.
before EMP, the customers were only able to utilize 70%, but after EMP, they are going to increase
Yeah,
the utilization to approximately 70%. And I'm going to
yeah,
talk more about how that can happen. And that's when the product that we have been working really hard from last 1 year,
hmm,
called Elastic Machine Pool. Like in short, it's EMP, right? So think of it as a new revolutionary compute engine. Keep mentioning this revolutionary because there's something we have done that no other competitors are able to do that, right? The most of the competitors in the market, they are actually giving you recommendation. They are actually using Spot instances to provision your workload, then destroying that, recreating it in other places. But they're not actually solving the root cause problem, which is the utilization. So all the tools that you use will help you decide, which will give you a lot of recommendation based on right sizing, but they will never do it by themselves because they want humans to get involved to make the decision, right? But EMP does it completely differently, and that's where the utilization problem is solved, right? So Kubernetes has a lot of underutilization problem that is get solved with this Elastic Machine Pool, which will ultimately reduce the cost of running EKS cluster by 50%,
right.
right?
So one quick thing here, Samsher. When you say you have to manually change, or let's say some of these tools you're using Carpenter,
Right.
assume, right?
Yeah.
Or whatever, and the tool will tell you, hey, you've got all these instances that are not being used, low allocation.
Right.
And then what happens? Do you have to go back to that the first slide you showed,
Mhm.
where the actual manifest, the YAML file
Right.
with the requests and the limits, you have to go back and change those? Is that what needs to happen in reality?
Yes. So l- remaining tools don't actually go and update your request limit. They
Yeah,
will just recommend you, right? So like you
yeah.
mentioned, the Carpenter, right? It is a new autoscaler
Mhm.
created by AWS, which is kind of like replacement for cluster autoscaler, which was the
Yeah,
default one, right?
yeah.
So if you talk about the cluster autoscaler, what it used to does is you provision, like I mentioned, four CPUs and 8 GB of memory,
Hmm.
and when that node is full, that cluster order scaler will provision the same capacity of node, right?
Mm.
But only one node is deployed on that instance. So rest of the memories are unused, right? So what it does, it just replicate the same node and creates another instance of the node to deploy the remaining unschedulable pods, right? So with
Smaller
Arc,
node,
yeah,
probably,
yeah.
right? Probably a smaller node to reduce the
Not
cost.
really. So previously,
Okay.
cluster autoscaler used to replicate the same node because it
Yeah.
does not know whether you need a smaller node or a bigger node, and that
Okay.
was the problem, and that's why the Carpenter get introduced. With
Yes.
Carpenter, you can actually, with the Carpenter makes that decision for you to
Mm.
decide whether this newly created pod needs a smaller node or a bigger node,
Yeah. Yeah.
right?
Okay.
And it does that by allowing customers to set up a provisioner on top of Carpenter. So that provisioner will have all the specification that
Hmm.
again dev streams or developers need to specify that which type of instances you want to provision for this workload, right? So you can
So
specify,
this is back to the original problem we talked about,
yeah,
right?
right,
So now you
right
have
in
to
the choosing.
manually, yeah, manually you have to now choose which
Right,
instances. If you still have to do that, the tool isn't really.
yeah.
I mean, here's the other thing, right? If you're a DevOps engineer or a developer,
Mhm.
you don't want to mess with any of those settings. If it's working, if the app is working,
Yes.
right, you are responsible for the SLAs, right? As a developer, your application needs to run with a certain performance and reliability, right?
Yeah,
And these limits, this memory, this is very important. You can't just mess with it, right? You
exactly,
can't change it,
exactly.
right? So that may be part of the issue, that people don't want to do anything quote unquote automatically.
Exactly, and that's
Yeah.
when most of the prospects that we have been talking to,
Hmm.
they actually start using Carpenter, but
Yeah.
they're not able to see the increased utilization, right?
Mm.
So the bin packing problem is solved. It is able
Yeah.
to give you the ability to provision smaller nodes, but
Yeah.
again, like I mentioned, the requested resources by pod is unused, and again, the problem for utilization is
No,
solved.
but Carpenter doesn't automatically reschedule the parts on a smaller node, does it?
It does, but you will have to actually specify in the provisional
Got it.
configuration,
Got
like
it.
which type of instances you want for this workload
Okay. You
to
have to
be.
tell Carpenter
Yes, yes,
what you need, and then
right.
Carpenter would automatically reschedule on a
Yeah,
smaller node. That's how you're solving the bin packing problem.
right, right.
Got it.
But
Got it.
yeah, again, like I mentioned, you will still have to specify those, right?
Yeah.
But
Yeah.
then a good thing about Carpenter is
Mm.
actually helps you select different instance types. It actually
Yes.
helps you
Yeah.
select and deploy this workload in
Yeah.
different
Yeah.
regions, which was previously not possible with
Yeah. The
Carpenter.
reason why I'm pushing on this, Samsher, because a lot of people just think Carpenter is there, it'll solve my problem,
Right.
but it doesn't sound like it actually does it. Does the it doesn't really solve the utilization problem at its core, right?
That's true. That's true.
Which is why you keep saying EMP is revolutionary.
Exactly.
So let's understand how EMP works then.
Yeah, yeah. So EMP, like Elastic Machine Pool, is
Mm.
fully compatible with all and existing and new EKS clusters. So if you already have EKS cluster deployed on AWS, you can
Mhm.
use EMP to migrate those EC2 instances to actually EVMs, right? And I'm going to talk about that
Yeah.
what it is, but
Yeah.
it does not impact your app SLA. That means it will not delete your pods and recreate it on another node. It will actually do that live migration from one node to another node, right? And
Mm.
I'll
Mm.
again going to talk about that in detail. But
Yeah.
the core part of this EMP is it does not affect your SLA, so your SLA is still maintained. DevOps teams don't need to really about worry about whether their SLA get affected if they
Mhm.
start using EMP, right?
Yeah.
And there is no configuration changes, there is no apps changes that you really need to do in order to
Mm.
migrate your application to EMP, right?
Mm.
That's why I keep saying that it's a revolutionary, because the underlying problem that we are solving is based on the utilization, increasing the utilization so that you will have
Mm.
to pay less cost, right? And
Yeah.
that's
No,
why,
but the other part of revolutionary is you don't have to do anything.
yeah, that's true.
This is very when somebody like a DevOps person hears this, they'll get very skeptical about it.
Yeah.
They'll say, what do you mean, I don't have to change my manifest, my application, there's no impact on my performance, I don't have to change anything. Now I'm getting really curious and possibly skeptical, so you need to convince me how EMP actually does
Sure,
that.
sure. Yeah, so that's where I'm going to talk about more.
Yeah.
So think of Elastic Machine Pool as a kind of like elasticity where you can use Elastic to
Hmm.
pack more things together, right? So if you
Yeah.
have a node, or one node or one machine, you can actually use elasticity of elastic machine pool to pack more nodes on top of it, so that whatever is provided to you, you can actually go ahead and use more of allocated resources that you have, right? So let's see. So once you start using EMP, this is something that you see. This is a dashboard, which is kind of like a saving
Mm.
tool that we have built to help customers understand how much they're actually paying with their EKS cluster, and how much they will pay if they start using EMP, right? And it's approximately, we will be able to save 50 to 65% approximately on their EKS clusters. So if they have like multiple EKS clusters with different nodes and configurations, we will be able to help them save approximately 50 to 65% of their EKS bills, right? And there are different things which is there, which I'm going to show you live after the discussion. But let's talk about how EMP actually works and what it does, right? So this is something that we did. We EMP will actually work with all other tools which is already available in the market,
Mm.
so you don't have to do anything else. Like, it can also work with Carpenter, it can also work with your cloud health, cloud ability tools, which is basically visibility, it gives you a visibility into your cost spends, right? And there is also a cube cost, which will provide you more detailed analysis of how much you are spending on your Kubernetes cluster on EKS, right? And there are a lot of parameters that we have highlighted here. One of the thing which actually platform 9 EMP targets is on the utilization part, which no other competitors are currently doing, right? They give you more visibility, but they will still put those decision making on the humans,
Mm.
right? And that's where, like mentioned, human makes more mistake on that area, right? So before we go and talk about how we did increase the utilization, let's first understand a basic structure of EKS, right? So what happens is, when you create a EKS cluster on AWS, your AWS will be control plane will be provisioned on one of the VPC, and then you have the ability to use either managed nodes, self-managed nodes, or Fargate pods, right? So this one is for the serverless part, but what we are going to target mostly is on the EC2 instances, managed nodes, right? So you have control plane and you have EC2 instances, which will work as a worker node, which will get attached to this EKS cluster, and then EKS will manage and deploy application on those specific nodes, right? Now, this is the standard architecture, and this is almost approximately same in most of the cloud providers. Like, you have control plane, you have worker nodes, and gets deployed on EC2 instances. Now, these EC2 instances are kind of like VMs, which is running on AWS, somewhere on the AWS, right? But they don't give you more control to actually optimize it for bin packing, or do more kind of like over provisioning, other things that we are able to do with EMP, right? So keep in mind that we will be targeting on EC2 instances, which will be managed EC2 instances, right? So with EMP, this is kind of like a very high level architecture. There are more internal details, but I want to abstract that and just show you what happens when you deploy, when you actually use EMP. So your EKS control plane will still be deployed on AWS environment, but instead of deploying worker node as a EC2 instances, what EMP does is it actually use bare metal server, and then deploys a EMP virtualization layer on top of this bare metal server. And then what it does is, instead of EC2 instances, it runs those instances as a elastic VMs, right? So you actually, this bare metal server is actually deployed on AWS only, right? And these EVMs will act as a worker node, kind of like EC2 instances, which will be attached to your EKS control plane. So what EKS control plane will see it as, it's still as a EC2 instances as a worker node, but under the hood, EMP actually uses bare metal server to create this VMs as a worker node, right? And that's where the magic happens, right?
Mm.
Because the EMP deploys virtualization layer on top of bare metal, which will help us increase the utilization. And I'm going to talk about that in the next slides, that how we actually achieve and
Mm.
increase the utilization. And that's when the
Yeah.
utilization problem of Kubernetes is
Yeah. So one
solved.
quick point here: you don't necessarily have to replace all of your EC2
Yeah,
instances with EVMs. They can work
yeah,
side by side too, right?
yeah.
That's
That's
just an important point we should mention. It's not like you have to migrate everything from what you have today
yeah.
to EVM. You can have them run side by side too, right?
Right, right.
Yeah,
So, for example, if you have some EC2 instances with ARM support, you can still run that on AWS environment. But other EC2 instances, which is x86 architecture, they can actually be
yeah.
deployed with EVM. So all of those run as a elastic VMs, and I will call it as EVM after this slide, so that it will be clear that these all instances are running as a VM, right? But in AWS console, you will still see that as a worker node, as a node group thing, which AWS don't know that this has been deployed on bare metal instances, because we do all kind of I would say a magic that will help create this VM as a EC2 instance, kind of EC2 instances, right? Now, this is one of the important point that I want to talk about. Now, like I mentioned, we use bare metal to deploy these EC2 instances or a worker node as a VM, right? And that's when we are actually able to utilize a virtualization layer to pack more VMs on top of it, right? And there is a concept on the virtualization which is called over provisioning. That means so if you use M5 Metal, bare metal server on AWS, which is having 96 vCPUs and 384 GB of memory, right? With virtualization or provisioning, you can actually deploy more EVMs and use more capacity, which is actually available on physical server, right? Which means you can actually double that resources limit, virtual resources, and pack more VMs on top of it.
Mm,
And this is not
mm,
possible with existing EC2 instances, even though those EC2 instances are running as a VM, right? But AWS don't provide this control to users for over provisioning, right? And that's when the EMP comes into the picture, which will actually help increase the utilization by over provisioning this bare metal server,
mm.
and that's where you will be able to pack more VMs on top of this bare metal.
So interesting. This is over provisioning is a pretty well known concept
Yeah,
in the virtualization
right,
world.
right,
The VMware, this has been around for decades. I mean, maybe 20, 30 years.
right, right,
And there were concepts such as dynamic resource scheduling, over provisioning.
right,
These were well known and well established, and people have done highly efficient data centers using this technology.
exactly.
So you're saying that doesn't exist on the public cloud?
Yes, and there is a lot of reasons behind that,
Yeah,
because like I said, EC2 instances are running as VM, but AWS don't allow you to over provision that,
yeah,
because if you over provision, it's basically a multi-tenant application, right?
right, right.
There are multiple other customers deployed on
So
AWS.
noisy neighbors, and there's all kinds of performance issues, and
Right.
but then you won't have the same problem with this.
Uh, we won't, because
Yeah,
for every customer we actually deploy a separate bare metal server. So once you have a bare metal, you have full control over it,
yeah,
and the more number of bare metals you use, you can
yeah,
actually pack more VMs on top of it, right? So let's see an example of this
yeah,
M5 metal, which is having
yeah.
96 vCPUs and 384 GB of memory, right? With over provisioning, like 2:1 ratio, which means that we can use double the capacity of M5 metal and try to add more VMs on top of it, right? So we can actually fit. So if you calculate all of these EVMs, which I've described here, it actually use 160 cores and 640 GB of memory, right? But the available resource on the M5 metal is 96 core and 384. So with
Mm,
over provisioning, you can actually pack more VMs on top of
mm,
existing bare metal, and that's when the magic happens. That's when the utilization gets increased, and
mm.
which is no other competitors is
So
currently
when you
able to
say
do.
utilization, you're actually referring to utilization of the bare metal server,
Yes.
correct?
Yeah.
So the utilization of the individual EVMs is whatever it is.
Yeah.
It's you're not changing anything there, right? It is
That's
what
true.
it is.
That's true.
But if things change and an EVM requires more resources, you're utilizing the underlying bare metal
Right.
memory,
Right.
and that happens automatically,
Yeah.
is
So
what you're
what
saying. Okay.
happens with over provisioning and virtualization is basically these EVMs are not
Hmm.
static, right? You can
Yes.
dynamically increase the size of these based on different techniques, which is available with virtualization. So if pod started to use more resources, I'm not
Hmm.
talking about requests, right? I'm
Hmm.
talking about usage, and
Usage. Yes.
that's when the magic happens, right?
Mm.
All other things, even the Kubernetes and other competitors that have been trying to do, they actually allocate resources based on the requested memory and limit, right? But EMP does that based on the usage. So what exactly your application is using, based on that, it will allocate the EVMs. It will fit more pods on top of these EVMs.
So there's an algorithm then, EMP actually measures
Yeah,
what's happening at the bare metal layer as well as the EVM layer on a regular basis, and
that's
then
true. That's
making
true.
these decisions. This is where the magic is. This
Yeah,
is where the IP is, right? This is how we are helping maximize utilization
right.
across all of these clusters. Okay.
Right. So let's talk about
Mhm.
that algorithm, which
Yeah.
actually makes the decision of how much the usage is and how much bare metal instances you need. Right. So
Mhm.
there is another concept we have been using with EMP, which is called live migration. And again, this is only possible with virtualization layer. Right. So what happens is, imagine that you have two bare metal servers, right, and you have fit certain EVMs on top of it, right? Now what, so that the EMP rebalancer, which is kind of like a heart of EMP, which makes the decision of where this different EVMs needs to be put, right? So based on the usage, when the pod started to use more memory, more resources, the EMP dynamically resized EVMs, and if it is not able to fit that, even with over provisioning ratios, what it will do, it will try to live migrate this EVMs to another bare metal server, right?
Mhm.
And that decision is made by an EMP rebalancer, right? So now again, previously I mentioned that with descheduler and other concepts in Kubernetes, they will actually delete your pod and recreate it on
Mhm.
another node, right? But with EMP, that happens live. Like that's why it's called as live migration, because those pods and nodes will not be destroyed and recreated. It will be live migrated from one instance of bare metal to
Mhm.
another instance where the capacity is available.
This
Right?
is pretty cool.
Yeah,
This technology again. I think this existed
everybody knows
in
about
the
it.
VM world for a
Right.
long time. But those who came from the VM world
They
will
already
get
know
this
about it.
instantly, right? They instantly get this.
Yeah,
But those who are born in the cloud, they don't know this.
exactly.
This is pretty. This is pretty magical in a way, right? Because you're saying there is absolutely no disruption
Right.
to the workload as you move these things across bare metal servers,
Right. And that's where,
right?
your SLA didn't get affected,
Right,
because
right.
all of these EVMs are live migrated from one bare metal to another bare
Yeah,
metal.
yeah. And all
And
of this is happening in real time, right?
yes,
Based on this algorithm.
that's true. That's true. So the live migration, under the hood, how it works is basically looks for the source bare metal, or the source node and the destination node, and it tries to identify how much capacity is available. Then it's try to, start migrating EVM from source node to destination node. It also checks the connectivity, the resource available on different destination nodes, and then start migrating the state. Now that also includes the CPU, memory, and storage. Right?
Mhm.
Once that migration completes, then it will change the state from one bare metal to
Yeah,
another.
yeah. No,
And
you made a very, very important point here.
yeah,
Storage,
yeah,
right? If there's no storage involved, then moving the compute is an easy thing.
right.
Now, talk about that because if customers have storage in an EBS volume or
Right.
an S3 bucket or whatever, how does it handle storage?
Yeah. So the EMP recommends using IO3 volume types, because
Okay.
that is having live migration capability of migrating your state from uh,
Hmm.
one instances to another. So what
Hmm.
happens is, those instances are the state of those instances are maintained during the live migration process, and there is
Hmm.
nothing new here. This live migration concept is already
Yeah,
using this capability. So what
that's
it
right.
does is, it will, so during the migration, if some of the state changes on some of the nodes, which is
Mm.
attached to EBS volume, it
Yeah,
keeps updating. It synchronizes both the volume types. It
yeah.
synchronizes both the nodes which is actually using it, so your data is not lost. It is still
Mm.
maintained, right? Once the migration completes, it move those state from one node to another node, right?
What about networking? IP addresses stay the same, connectivity stays the same. How does that work in this situation?
So I think the networking gets updated once this EVMs are moved to different bare metal, because
Hmm.
the bare metal will have different networking attached to it. But that
Hmm.
also happens live. That
Hmm.
does not disrupt your application, and that's where the SLA gets maintained, right? But it takes care of updating and verifying all the resources, network connectivity, storage, all the things like CPU, memory, storage, everything will be taken care by this.
So this is pretty amazing.
Yeah,
This is where the magic is happening, right? This is how
yeah,
you're automatically improving utilization,
right,
but you're doing so at the bare metal layer,
right.
right? And then everything else is completely transparent.
Exactly, right. but
Wow.
but in AWS you won't see this magic, right, from
Yeah.
the UI. So for
Yeah.
for AWS it's still the same. It's still it will treat it as EC2 instances, but under the hood EMP will take care of doing all this magic for you.
Yeah. So for the developer, for the DevOps person, all the operational tooling they have, all the automation they have,
Right.
if they're using kubectl, I
Mm.
guess, or
Right.
APIs, Kubernetes APIs, or if they're doing upgrades,
Mhm.
none of that, everything will be look exactly like it's an EC2 instance as far
Exactly.
as they're concerned, right?
Exactly, right.
Hmm.
So I'll show you that once
Yeah.
we go
Yeah.
into the demo part, that
Yeah.
you can still see EKS control plane nodes, you can still see EC2
Yeah.
instances, but
Yeah.
it will
We just a
as
time
EMP.
quick time check. This is super interesting. We got into
Perfect.
the real core of how this works.
Yeah.
Um, is there anything else? Can we see what the product looks like real quick?
Yeah, definitely. Before that, I just
Yeah.
wanted
Yeah.
to
Yeah.
highlight one of the prospects data that
Mhm.
we actually run to help them save
Yeah.
44% with EMP. So this
Mhm.
was deployed on US East region. These are the
Mhm.
couple of instance type that they've been using, which was costing them $12,000.
A
But with
month.
EMP and over provisioning, all of these instance types can be fit into only two M5 metal
Mm.
instances, right?
Mm.
Because we use over provisioning to double the resources which is available on the underlying physical bare metal server, we are able to fit all of these instances into only two bare metal servers, right?
Yeah. Yeah.
So they actually saved 44% on their EKS billings, right? And one of the other prospects that we have been working with, they are actually able to save 58%, which is approximately 8 million in saving for them, right? And that includes 4 or 5 regions where their different instances have been deployed. Now,
Yeah.
like you mentioned,
Mm.
they've been previously using different instance types, different configuration based on the application that they've been deploying, right? So they have to make all of these decisions previously, but it happens automatically with EMP, right? Because
Mm.
EMP recommends based on like M5 8X latch, which is kind of like fit multiple pods on a specific node, and which will work perfectly with M5 metal instances.
Mm.
Perfect. So let's go and jump into the demo. I'm not sure I'll be able to complete all of them, but I'll quickly show how we build that product and how it looks, right?
Yeah.
So me so this is the I'm just using a staging environment for us to log in, okay, and demonstrate. I think based on the current time check, I'll not be able to run all the commands because that's
Yeah, I
take some
think
time.
Samsher, we should. This is so cool. We should actually have a completely separate live stream
That's true.
to dive into the product demo. But today, just show what's available
Yeah,
and what people, just what the user interface looks like, and
yeah,
the dashboard, especially the savings part. Right, that
right,
would be
right.
cool to see.
Yeah, sure. So let me log in. So once you log in, you actually have two options. One to actually see how much you can save with EMP. Then the other part is going ahead and creating the EMP. So the cost saving dashboard that we have built, this is one of the data that we have pulled from one of the customer from one of the cluster, right? And this is a cost saving dashboard which will actually help you realize how much you can actually save with EMP, right? Like I showed in the slide, we are able to save 59% on the EKS billing. So with EKS, they've been paying like this amount, but with EMP, they only have to pay for this one, right? And this is running for a couple of days, not for a long time, right? So if I just go and say 30 days, right? So this blue bar that you see here is actually the cost with EMP, the cost with EKS, And with green that you see here is basically a cost with EMP, right? So you can see the blue bar is larger because with EKS you will have to pay more. But once you start using EMP, all of your EC2 instances or some of your EC2 instances can be moved to you know bare metal server with EVMs. You will be able to save a lot of cost from that, right? So all you have to do is once you want to try this tool out, you'll have to connect with sales team and they will help you create the credentials. Now the first thing that you will have to do is come to this part and click on installer option, where you will get a helm chart that will help you that will help EMP to collect different metrics from your cluster, so that we can provide you how much you have to pay with EKS and how much we can save with EMP. So once you install this helm chart into one of your EKS cluster, we will start collecting different kinds of metrics which is mentioned here, so that we can give you what is your current utilization, what is your current billing that you will have to pay with EKS, and then based on that what we recommend from
Mm.
EMP perspective and how much you can save. So we've deployed this into one of the EKS cluster, and that's why it's showing installed. And then once you go here, you can actually go ahead and see that in the last 14 days, this is how much you will be paying with EKS, and this is how much you will have to pay with EMP, which is approximately 60% cost reduction.
Mm. Is this an estimate or is this real actual savings?
So this is basically a projected one,
Okay.
because because
Yeah.
your usage keep changing, right?
Yeah.
Like
Yeah.
if you give you the exact numbers, and
Yeah.
if your usage gets increased, these numbers will get reflected based on your
Understood. But
usage.
you can also show historical, right? How much you have saved.
Yes, definitely, we can
Yeah.
we can do that, right?
Yeah. Okay.
Right.
No, this is
So
fantastic.
yeah,
So all of this cost visibility is built in to the product. You can
yeah,
actually see how much you're saving.
right.
And
That's
the other thing we discussed earlier is you don't have to move all workloads to to EMP.
right,
You can continue to run them on EC2 if you want to use ARM, as you said earlier,
right.
or if you have some specialized things, or whatever reason, you may not want to. This is a new product. You want to test it out. You want to do POC.
Yeah.
You can do that without disrupting anything. You can. How do you do that exactly? Do you kind of set up some rules and say send them parts to EMP, or how does that work in a
So
POC environment?
yeah, so to do that, you will have to actually create the EMP and select different configuration for your instance types, right? So I'm not
Okay.
sure I'll be able to show that, but what
Yeah.
I'll do, I'll just go
Yeah.
ahead and show you one of the EMP that we have created, right?
Yeah.
So once you create the EMP, uh, uh, you can see that it's in the created state. It is having one cluster attached to it. It's in a healthy state, and it is running 14 worker nodes as a EVM instances, right? I'll just go and click on it. Here you will see a different configuration for a bare metal, how many EVM pools you have created, and how many EVMs or worker nodes it's actually running. It's also giving you a CPU and memory utilization. So, like I mentioned, what we do is we actually create a bare metal server and then deploys different EC2 instances as a EVM, right? So you can go and actually go and see how many machines we have created for bare metal, what is the state of it. So we have actually used M5 metal to create that, right?
Yeah.
And then once you go into the EVM pool, you can see that approximately 14 EVMs, which will act as a worker node for your cluster, right?
Mhm.
So you can see all the status from this panel. Let me quickly go into the EKS and then show you the exact same instances that we have created here, which will get reflected as a worker node, right? So I'm just keeping this open, right?
Yeah.
So you have 14 instances, and let me go to console and EKS. Okay,
So this is the seamless integration you were
right.
mentioning earlier. Everything is also shown from the EKS dashboard.
Yeah, that's true, and that's why you don't see anything different
Yeah.
from the EKS perspective from AWS perspective, right? So
Mm.
first, I'll show you a bare metal instance that we created, right?
Yeah.
Okay, I'm not able to click here. I'm not sure why. So first, let me show you. This is the EMP cluster that we
Mhm.
created for demo, and the different 14 nodes that you were seeing that as a EVM instances is attached here to the specific cluster, right?
Yeah.
That's what I was trying to show, that we created almost 14 worker nodes. This will work as a worker node.
Yeah.
Uh, but from the EMP perspective, this is kind of like a VM, so that we
Right.
can
Right.
resize that, fit more, pack more nodes on top of it. Right.
Fantastic. This
I,
is really awesome. So we are out of time,
yeah.
but one quick thing I just wanted to leave the audience with is that we are actually running a early access program. So if people want to try this out in their environment, we're going to provide free bare metal instances. We'll provide full support from our solution architects and from our very able engineering team to help you get this up and running, to see for yourself how easy is it to first get it up and running and see cost savings. How soon can people see cost savings, Samshare, once they get this up and running?
So once you deploy your Helm
Mhm,
chart onto one of your EKS cluster, we will
mhm,
take approximately 1 hour to collect different metrics, so that we can,
mhm.
suggest you the better
Yeah,
savings, right? But the
yeah,
more time you spend, keep running those
mhm,
Helm charts, like
yeah,
configurations, the
yeah.
better the recommendation will be. Right?
Yeah, perfect. And there's the URL to the early access program.
Yeah.
It's available on our website. Just go to platform9.com/elastic machine pool/early access. And you can fill up a form. You can see what you get during the program. It doesn't take, I guess, a couple of weeks maximum, where you can work with our team and we will get EMP installed. You'll get full support from our team and you can see the savings for yourself in your own environment. Maybe you pick something that's non-mission critical, maybe a dev test cluster,
Right.
and get up and running pretty quickly. And you can see how the whole thing will save you a ton of money and see how easy it is. You don't have to touch anything. That's the beauty of this whole approach.
Right.
So, Samshare, this has been super enlightening. This product is truly revolutionary. Right? I can see why you keep saying it's truly revolutionary. It
Right.
is. There's no such thing available in the market right now. The public clouds don't do it. None of the existing tools actually solve the problem at its root layer. So we are excited to launch this product, getting this into customers' hands, and obviously we'll continue to iterate and make it better over time.
Yeah. I hope you have shared the link of the website for Elastic Machine Pool, so that folks can go
Yes.
ahead and see that.
Yeah, it's platform9.com/EMP.
Yeah.
So, or Elastic Machine Pool. Either one should work.
Yeah.
Go in there. There's a whole ton of, I mean, obviously, we went into a lot of depth in this live stream,
Yeah.
but EMP website will give you a kind of a high level overview and
Right.
you can sign up for a demo if you want to see in your environment. So, with that, we'll wrap up today's live stream.
Yep.
Super great session, Samshare. Always a pleasure to have you
Thank
in
you.
these sessions. You're highly knowledgeable. You know what's going on. You're the product manager, right? So you
So,
you own this product. So
before
yeah,
product
yeah,
manager, I
yeah,
was a
yeah,
core
yeah.
developer. I've spent
There you go.
almost more than
Yeah,
5 years in Kubernetes. So
in
yeah,
developing Kubernetes applications, right?
that's
So
that's true.
so there
That's
you
true.
go. Yeah. So
Perfect.
yeah, with that we'll wrap up today, and I look forward. I think we should probably do a more deeper demo, actual demo,
Yeah. Sure.
to show the product in full detail in a future session. So we'll
Sure.
we'll catch up again with you, and we'll look forward to come back and have another live stream.
Sure.
Thank
Thank
you
you.
so much.
Yeah. Thank you. Have a good
Bye
day.
bye.
Bye.